Trigonometric ratios for special triangles. Now this one is a special triangle with 90 degrees. Now normally when we talk about special triangles, we are talking about 45 degrees, 30 degrees and 60 degrees. 90 degrees and 0 degrees is kind of skipped most of the time, but I think it's most important. And I'll take your moment here to explain you what is 90-degree triangle. So let me first draw a coordinate plane here. And we are actually restricting ourselves to quadrant 1 since we are saying we are working in for an acute angle. So acute angle is between 0 to 90 degrees, correct? So that is why most of our examples so far in this playlist will be restricted to 0 to 90 degrees. So basically we are considering acute angles. Now here I'm telling you, but these concepts, they work for all angles, correct? Now let me make a triangle with 90 degrees. Well, let me start like this. So let's have a triangle here in general in quadrant 1. And let's say this is my triangle. And let me use different colors so that we can say which side is which side. Okay, so that gives us a perpendicular here, right? That's the origin O, right? And from here we have a triangle, and I'll call this side as the opposite side and this side as the adjacent side A, and that my angle here, I will call this angle as A, angle A. Okay, so I know I have a vertex here by the name O and I've named angle A. Normally name of the angle should be same as the point here labeled, right? But since it is kind of origin on a coordinate plane, I made it O, and A stands for my acute angle actually. And I'm not using Greek alpha since some students get scared with the name alpha itself. So I'm using a very user-friendly name A here, okay? So A is my acute angle, correct. Now in this triangle, we know Sohcahtoa, and Sohcahtoa is sine, cos and tan definition. Easy way to remember what sine is, with what cos is and what tan is. So Sohcahtoa is something like this. We say sine is opposite over hypotenuse. We write opposite over hypotenuse, right? So let me label this as hypotenuse. So that becomes sine. And so sine is, we can write this as sine of A, angle A is equal to opposite over hypotenuse. Opposite over hypotenuse. That is so, the Sohcahtoa, the first three letters. And now Sohca, and that ka is kind of C for cos, adjacent over hypotenuse, A times H. And that is cos. And let me write this cos in red for the time being. And say cos A is equal to this side, adjacent side. Adjacent means adjacent side between 90 degrees and our acute angle A. Okay, so that is A over H. That is Sohcahtoa. Toa is for tan. Now for tan, let me use this ink and we'll write tan Toa, O over A. So that is T O A, O and A, right? And they write tan T A N, A is equal to O over A, right? O over A. So these are our three primary trigonometric ratios. Now we will see what happens to these ratios when our angle A becomes 90 degrees. So what I'm trying to say here is that I'm going to move this arm of the angle, that is my initial arm, right, along the x-axis, let us say, right? And this is my y-axis. Now we know y and x-axis are at right angles, correct? So when we are saying 90 degrees, I want to make that angle as big as 90 degrees. This is what I'm going to do. And it can happen if I move this point in this direction, correct? So if I move like this, as I move it upwards, you see what happens. Let's say I'm moving this arm which is also called my terminal arm of the angle. As you know, if I'm moving it counterclockwise, I know the angle is positive, right? Counterclockwise angles are always positive. So as I'm moving it in this direction, angle A is increasing, right? As I move from here to here, angle A is increasing. If I move it here, angle A is further increasing. Do you see that? So we have an angle A which is kind of that much. It's closer and closer to 90 degrees, correct? Now see what happens. As angle A increases, that is, as I'm moving this arm counterclockwise, and I'm thereby increasing the angle from whatever to 90, right? As we go higher and higher, it becomes like, for example, let it be 40 here, then 45, 50, 60, 75, 80, 85, 90, right? So that is what we want to achieve. And we want to see what happens as A becomes 90. Well, let's compare a triangle here with this triangle where the angle A is, let us say, around 40 degrees, with here where, let us say, the angle is around 80 degrees. You will notice that the opposite side has increased, you see, very high, and the adjacent has decreased, right? So what we see here is that as angle A increases, right? So we are increasing angle A. So what are we doing? Angle A is increasing, right? Angle A increases. What happens? O, opposite side increases. O increases, right? And what happens to adjacent side? Adjacent side decreases, correct? How about hypotenuse? Hypotenuse will remain same, right? It remains same, right? Because it is my radius, right? Hypotenuse is my radius, right? It's the radius of circle, so it remains same, correct? So hypotenuse remaining same, O increases and D decreases. If O increases, what happens to sine? And hypotenuse remains same for both of them, right? For here also. Now if this remains same and O increases, sine increases, correct? So what happens when angle A is increasing, right? If angle A is increasing, we see that sine is increasing. Is that okay? Sine is increasing since the opposite side, O, is increasing, but H is same. But how about cos? Cos will be decreasing, correct? Cos will be decreasing. How about tan? Tan will be increasing also, right? And tan will be increasing faster. Faster because A opposite is increasing and A is decreasing. So it increases much faster. So I'm putting 3 arrows here. Much faster, right? Faster than sine, because here H is constant, correct? Now imagine, so that means we know this opposite side is as close to this hypotenuse. Do you see? Now let me take it to the extreme. That is, let me push this just here along the y-axis. Now my angle A has become 90 degrees. What happens to O? So as angle A, I'm saying angle A, let me write angle A like this. As angle A approaches 90 degrees, so what happens? What happens to O? O becomes closer and closer to hypotenuse. Do you see? O becomes, this is O, right? So it becomes almost same as the hypotenuse. So O becomes closer and closer to hypotenuse. And what about adjacent side A? A becomes closer and closer to 0. Do you see that? I'm not writing O here. I'm writing 0 to be very clear, right? Because it is decreasing. O is decreasing, right? So let me write, this is kind of decreasing. A is increasing. So it increases to almost hypotenuse. And this decreases to almost 0. Do you see that? So A becomes almost 0. So when A is approaching 90 degrees, then what happens to sine? O becomes closer to H, right? So sine becomes, like O becomes closer to H. Therefore, sine A is what? Sine A at this time is hypotenuse over hypotenuse. That is 1. And that is the maximum value a sine can have, 1. And it is only when sine angle A becomes 90 degrees. And therefore, sine of 90 degrees is 1. Remember that, okay? Now we have understood what sine is. Now let's check what happens to cosine. Now for cosine, as we approach 90 degrees, a approaches 0. Do you see that? It becomes almost 0. Therefore, cos of 90 degrees will be 0 over hypotenuse, and that will be equal to 0. And therefore, we have cos of 90 degrees is equals to 0. Perfect. So this is what you should always remember. These are also special triangles, right? And how about tan? Now tan is very difficult to understand. Now what happens to tan is that tan of O becomes almost hypotenuse and A becomes almost 0. So we can write hypotenuse over A becomes almost 0. So that's a number 0. But you can't divide by 0, correct? So for tan of 90 degrees actually becomes infinity, very, very large. It is undefined. And we say it is almost infinity. It is infinity, something over 0. So tan takes a very, very large value as you approach 9. So at 90 degrees, tan actually is not defined, right? Because 1 over 0 is not defined, correct? So that concludes our results for this special triangle of 90 degrees. So we can say sine of 90 degrees is equal to 1, cos of 90 degrees is equals to 0, and tan of 90 degrees is undefined. Okay, so that is the final conclusion of our special angle 90 degrees, and I hope you understand how and why we get these values, correct? Thank you.